So let me talk about natural gas. Department of Energy has, over the years, from 1978 to 1992, this is the amount of money we funded in horizontal drilling and hydraulic fracking of natural gas. And as noted by Fred Julander of the National Petroleum Council, the Department of Energy was there with research funding when no one else was interested. And today, we're reaping all the benefits. Early DOE R&D in tight gas sands, gas shales, and coal bed methane helped catalyze the development of technologies that we're applying today. And so this blue line is where we are today. The price of natural gas is now about $2.60 per million BTU. Probably won't stay that low, but it's certainly, we feel, going to be in a very low range, maybe $4, $5, $6 a million BTU for perhaps even decades to come. So this is very good news because it gives us, we feel, more than doubled the reserves of natural gas, and it's made natural gas very inexpensive. Can we use natural gas for transportation? Well, for a 18-wheeler, it's no longer a debate. Even though the 18-wheelers could cost 50 or even 100% more than a conventional truck, and that price is going to come down very rapidly because now there are competitors. A natural gas truck costs about half, in terms of the fuel per miles driven for the same size truck, it costs half as much, roughly $2 an equivalent gallon. Liquid nitrogen trucks can go 500 to 650 miles, and so in 2 to 4 years, with today's natural gas prices, and today's diesel prices, conservatively 4 years it pays for itself. But you hang on to these trucks for 10 years. And when the price drops down to where we think it would be, maybe 30 or 40%, 30% more expensive than a conventional truck, then it'll be paying for itself in perhaps 2 years. Today's batteries, for example, look at the Chevy Volt and Nissan Leaf, you're talking roughly $10,000, $12,000, $15,000 battery. Very, very expensive. NTEA, a company we funded in the Department of Energy, has just announced, just a week ago, that 400 kilowatt hours per kilogram is here. So what does that mean to you? Well, it's double the energy density of the battery without increasing the cost whatsoever. So this is a package of these new batteries. Our goal is so now we think the batteries will go from roughly $600 or $700 a kilowatt hour to maybe $300 a kilowatt hour. Our goal is to reduce the cost of these batteries to $125 a kilowatt hour before the end of this century. What will that do? If the battery is that inexpensive, we're actually halfway there. We're about 4 years ahead of schedule, so this was quite a surprise.